what an exponent is. Okay, so 4 to the third power. If I have 4 to the third power, does that mean 4 times 3? No, right? What does that mean? What does it mean when I do 4 to the third power? The big number times itself that many times. The little number tells me how many times am I going to multiply, right? So 4 times 4 times 4, which is 64. 4 to the second means take that big number and multiply it twice. 4 times 4. You guys probably already knew that. 4 to the first power, it says take that big number and multiply it once. So that's why it's just 4. Okay, and then I'm going to stop right there for a second. Okay, so let's look at the pattern first. There's a couple patterns going on. There's 3 patterns, or 2 patterns going on, really. So let's look at the left pattern. What's the pattern here? Yeah, the little number is decreasing by 1 every time, right? 3, 2, the big number's staying the same. Base is staying the same. Okay? Let's go to the middle. What's the pattern here? What's happening every time? It's getting smaller, right? What are we losing every time? A 4. A 4 is disappearing every time, right? Okay. So let's go to the third. Getting smaller still, right? We were getting smaller on the first column, the second column, and still the third column we're getting smaller. But can we be a little more specific with how much we're decreasing? So you have 2 ways. There's 2 ways to decrease, right? I can subtract or divide, right? Those are the 2 ways to decrease. Which one is this? Division, right? It's more of a division than subtraction, right? What are we dividing by? 4. So I'm dividing by 4, and I'm dividing by 4. So if I keep up that pattern, what should the next number be? 1, right? It should be a 1, positive 1. So that means this number is a 1. So let's go back to what that means. Why does 4 to the 0 power make 1? I get a lot of students that say 0. Well, it doesn't fit the pattern. 0 doesn't fit that pattern. 1 does. In fact, I could do a table like this for anything. Any number, any base to the 0 power, change it to a positive 1. Just change it to a positive 1 because that's what it fits the pattern. This could be a 5. This could be a 6. This could be a 20. This could be a million, right? But it would fit that same pattern. Okay? So let's keep it going with that pattern. Divide by 4. If I were to divide 1 whole into 4, what would I have? 1/4, right? A little bit of mental math. If I was to take a 4th and divide that into 4, what would I have then? So let's see. This is what you're doing. I'm going to give you a little picture to show what you're doing in your head right now. So we have a whole, right? And I divided it into 4. I got my 1/4 there, right? That's 1/4. Now what I'm asking you to do is only take that red section and cut it into 4. And only take one section here, the green section, this green little slice here. What part is that green of the whole circle? Not 1/8, you're close. 1/16, right? Because each one will have 4, so 1/16. Okay? So let's go back here and put 1/16. 1/16. So if I give you a question like, what's 4 to the -3? I don't want to have to draw a picture every time. So what's the trick? There is a trick. I'll show you. Anytime you have a negative exponent, the biggest answer I hit, so I'm telling you right now, the biggest answer I get this question on a test or a quiz, I have students putting that, or students putting this. It doesn't make negative numbers, right? Why doesn't it make negative numbers? Because it doesn't fit the pattern, right? There's a pattern here, divide by 4, divide by 4, divide by 4. Negatives don't happen. So don't change it to a negative, right? What's the shortcut way? Well, let me show you. 4 to the negative 1, right? I have a 4 up here, but what happened to it? It went to the bottom, right? It went to the bottom. So the quick way to saying, if I have a negative exponent, move it to the bottom and make it positive. And if there's nothing on the top of a fraction, it's always 1. That's how I get that. Same thing with this guy. Move it to the bottom. The power becomes positive now. 4 squared, 16. So what would this guy be? What would 4 to the negative 3 be? 1 over 64, right? Right? What you guys just did there was rule 5. Rule 5. That's rule 5. Okay? Anything to the power of 0 is always going to be 1. I don't care what number, what letter, what variable, what anything. It could be long, short, medium, skinny, fraction, decimal. If it has a 0 power, it's always going to be 1. Okay? So the rules there, like I said, if you haven't written them down, they're on the board. I'm going to leave them on the board. You can write them down for your notes. I'm going to leave them on the board for tomorrow, so make sure you have those written down. Okay, so let's use those powers now. So go to the back. We're going to use those powers. Now I'm going to go slow. If you need to go faster, go faster. But I'm going to go slow because I don't want to lose anyone. Okay? So you're going to see the word simplify a lot. What does that mean when you're doing exponents? It means 3 things. Parentheses first. So all of those rules with parentheses, 3, 4, 6, 7, that's the first thing I'm going to do. Once there's no parentheses, then I'm going to move to the negative exponents, those rules. Once I'm done with those, I'm going to do everything else. Okay, so let's do that with 1a. Parentheses. Are there any parentheses anywhere on this problem? No. We don't have to do any of those rules then. Negative exponents. Are there negative exponents? There are. So I'm going to circle those. We have a negative exponent here and a negative exponent here, right? How do I make those positive? How do I make those exponents positive? On the front side, then I move it to the bottom. But now they're already on the bottom. So what do you think I'm going to do to make them positive? Move them to the top. Do the opposite. If they're already on the bottom, move them up. Okay? So what is that going to look like? It's going to look like this. That x to the negative 2 is not going to be negative 2 anymore because it's at the top. It's going to be x squared. The x that was already there, what power does that have? It doesn't have a power, but what power is it? 1, right? If there's no power listed, it's always 1. This guy right here, the last guy, x to the negative 1, needs to move up. When it moves up, it becomes positive. What's left on the bottom? 1. There's always a 1. Yeah, not a 0, always a 1. Do I have any negative exponents? Nope. Skip that step. Or not skip it, we're done with it. Next thing is simplify. Mainly rules 1 and 2. We have x's, right? Are they on the same level or different levels? Same level, right? So what do I do with their exponents? Add them together. Add them together. So I get x to the 4th over 1. You don't have to write that 1 on the bottom if you don't want to. It's just already assumed, so you can write it like that. Done. Okay. Let's go to the next guy. Parentheses. Are there any parentheses? No. Nope. Skip that step. Negative exponents. Do we have any negative exponents? I have 1, 2 of them again. They're at the top. To make them positive, what do I have to do with them? Bring them down. Yep, bring them down. rewrite. So I have y. If y is by itself, it's always got a power of 1, right? So y1. And then now I have x1, x3, and a new y1. x1 moved to the bottom. That's where that guy comes from. X3 did not move because it had a positive exponent. Y negative 1 moved down. Okay. Any more negative exponents? No. Last step. X's. Are X's on the same level or different levels? Same level. So I'm going to add their exponents. X4. Y's. Same level, different level? Different level. So we don't add them, we subtract them. So what's 1 minus 1? 0. They cancel each other out. Not 0. They actually divide to make 1. So there's technically a 1 here and a 1 there, but you don't have to write the bottom one. The top one we have to because there's always something. So this one is just like that. Okay. When they cancel each other out, when their powers go away, they just become 1s. Okay. All right, so now 2a has parentheses now. So we have to deal with those parentheses. That's the first step. I have negative 4 and x. What are these two doing with each other? Are they adding, subtracting, multiplying, or dividing? Negative 4 and x. Multiplying, right? What power does negative 4 have? A 1, right? No power means a 1. Same thing with x. Okay? Parentheses. So let's go to my parentheses. Let's go to my... I don't have just one thing in there. It looks like I have multiple, so I'm going to use step 4. Step 4 says that power on the outside, give it to everything that's on the inside. Kind of distribute it. Okay? So, I'm going to distribute here and distribute here. So what is that going to look like? It's going to look like this. Negative 4 already had a power of 1. Now I'm going to give it a power of 2. X already had a power of 1. Now I'm going to give it a power of negative 2. So I distributed negative 2 to both. What am I going to do with the powers now? That's step 3. Multiply. You get negative 4 to the negative 2 power and x to the negative 2 power, because you multiply. Negative 4 I kept in parentheses just because it's a negative and a negative. I want to keep them separate. You don't have to have that parentheses there. But I do it because when I have two negatives that close to each other, I make sure I separate them. Okay? So even though there are parentheses, there's not really parentheses. Okay? So I'm going to go to the next step. Negative exponents. I do have 2 with negative exponents, right? I have that guy, and I have that guy. How do I make the exponent positive? I have 2 options. Move it down or move it up. Which one am I going to do here? Down, right, yeah. How do you know when it's down or up? If you don't know, these guys are on the top. You'll know if it's on the bottom. But if you don't know, there's always a 1 on the bottom. There is no fraction, make one. Move this guy down, move this guy down. So now I have 1 on top, negative 4 to the positive 2 power, and x to the positive 2 power. So that 1 was up there already. It's not this one. That 1 is still on the bottom. It's like right here or right here. But the 1 up here, because if it goes away, there always has to be something there. Okay, so what is negative 4 squared? What is negative 4 times negative 4? Positive 16, right? So multiply, simplify, and you're done. Okay. Next one's very similar. Next one's very similar, just with no parentheses. So it's still negative 5 times x. Who owns that negative 1 power? Does negative 5 own it? Does x own it? Or do they both own it? Just x, yeah. Negative 5 has its own power, positive 1. They don't both have a negative 1 power. If they did, they would have written it like this. They didn't. So we don't have to do any parentheses. Negative exponents. Well, there is no fraction, so that means it's on top. Move it to the bottom. So negative 5 to the first power, x to the first on bottom. You're done. Negative 5 stays on top. I had a lot of students do this last year. Not a lot, but I did have a few do this. They put that as their answer. And they gave me two different answers. First thing they said was, oh, is the negative 1 goes with the negative 5. We just said it didn't, right? The other reason why they're like, oh, negative 5 was negative. Doesn't it go down to the bottom if it's negative? No, it only goes if it has a negative exponent. Negative exponent. Okay? All right. Now we're going to mix up some rules here. Okay? So here we go. Same thing, simplify. Same rules. Same these guys. Parentheses. The top has parentheses. So I'm going to deal with that first. Okay? Each of these guys is going to get a 0 power, right? Negative 3 doesn't have a power. It's actually 1. So negative 3 to the first gets a 0 power. Q to the negative 3 gets a 0 power. Bottom stays the same. Because each of these guys got a 0 power. Now I can multiply. A power to a power is rule 3. Multiply. 1 times 0 is 0. Negative 3 times 0 is 0. So I get negative 3 to the 0 power, q to the 0 power. Bottom stays exactly the same. Rule 8, anything to a 0 power becomes 1. So you can do this now, you can do it later, it doesn't matter as long as you do this. This becomes a 1, that becomes a 1. Anything to the 0 power makes a 1. So I have 1 over negative 6 times q negative 6. Negative exponents. It's on the bottom, it's got to move up. So I get 1 times q to the 6th over negative 6. You don't have to write that 1 in the front. You can if you want. You're done. Negative 6 stays on the bottom because its power was positive 1. Okay? All right, what I want you to do is try B. Now try B. Top of the next side, try B. It's just like this one. Try it right now on your own. We'll do it together. But I want you to use the ones we've done as a guide to do B. Okay, see what you get. Okay, no more negative exponents. Simplify. B's are on the same level. So I can add them together, make 17. So I get negative 3 squared, B 17, negative 12. So if you were to put that answer, you wouldn't get full credit. Why? Because I haven't simplified it, finished simplifying it. What is negative 3 squared? What is negative 3 times itself? Positive 9, right? And then 9 and negative 12 can simplify. You can divide them both by 3. Divide that by 3, divide that by 3. Fully simplified now. 3b17 over negative 4. Okay.
Did you mean to put negative 3 on the bottom?
Did I mean to put what?
Negative 3 on the bottom.
No, 3's got to stay on top because its power is positive.
No, I'm saying.
Did I put it
Red.
in the red? Divide by 3. Divide by 3. I divide them both by 3, right?
It's negative 12 divided by 3.
Yeah, I divided by 3. So negative 12, yeah.
Oh, those are your units.
Yeah, those, that's, yeah, I didn't divide, yeah. I see what you're saying, yeah. I did dividing in my head, yeah. Good question, though. If you have a question, please ask. Okay. All right, so C, we're going to do together. D, you're going to do on your own. You're going to do there's one question on the exit ticket, and we'll be done for today. Okay? We'll be done for today. Yep, we got plenty of time. All right, so here we go. Parentheses. Parentheses first. The top doesn't have parentheses, it's going to stay. 15 to the first power. R to the sixth power. C to the negative 8. Bottom is going to get every one of those terms is going to get a negative 5 power. C to the first, negative 5. Okay, so the bottom I'm going to multiply the powers. That'll get rid of the parentheses. So I'll have 3 to the negative 5, R 15, C negative 5. Top, I still have 15 to the first power, R to the sixth power, C to the negative 8 power. That's usually the step where students struggle the most. It's this first step with parentheses. Negatives, you're good on, simplifying you're okay on, but it's just that first step. If there's parentheses, multiply or distribute. Negative exponents. Negative exponent's got to move up. Negative exponent's got to move down. Negative exponent's got to move up. So on top, I'm going to get 3 to the positive 5 power. 15 to the first power. You don't have to write first power anymore because it's just 15. R6, because it stayed. And C5, because it moved up. The bottom is just going to be R15 and C8. R15 was already there, and C8 because it was negative 8 before. No more negatives. Simplify. R's, they're on different levels. Different levels. That means subtract. Okay? So when you subtract, you get 9 or negative 9, right? So what happens? Well, we don't want any more negative powers because I already dealt with that. So this is how you do it. This is how I do it. If I subtract 6 and 15, I get 9, right? Where are the leftovers going to be? Where are the extra parts going to be? On top, if I take away, where are the extra parts going to be? On the bottom, right? 6 doesn't have enough. And 15 has the rest, right? So that means R9 is going to be on the bottom. Same thing with C. C5 and C8, I know I'm going to have 3 left over. Where are they? On the bottom. On the bottom because that's where most of them were. The leftovers stay where most of them were. And then I have 3 to the 5th times 15. That you can use your calculator. I believe it's 3,645. If I remember correctly from last period. So I just literally put that in my calculator. 3 to the 5th and 15.
Shouldn't you see the power to 3?
Yes, yep. Sorry, yep. It was 3 left over, so it should be 3. Thank you. Yep. So how did I get 3,645? 3 times 3 times 3 times 3 times 3 times 15. Okay? That part your calculator will tell you. All right, so what I want you to do is do D. Do letter D. We'll go over it together. And then the last 10 minutes or so, that'll take you about 5 minutes, maybe less. The last 10 minutes, we'll do this exit ticket and we'll be done. Like I said, that negative power only goes with W. -3 does have a power, but it's just 1. So if you want to give it a 1 power, you can. You don't have to. So when I multiply it, it makes -4. Okay. Negative exponents, W needs to move down. J needs to move up. So we get -3, J6, 5, W4. You can put the 1 power, doesn't hurt anything. Can I subtract 6 minus 4 to make 2 power? No, because they're not the same. So what can you do? Nothing. That's it, you're done. Because -3 and 5 can't be reduced. So you're done. Okay? All right, so on the exit ticket, one side you're going to put your name, the other side you're going to do the problem. Because I don't really look at names when I'm doing this, I just want to make sure that everybody does it.